Thank you for coming to my TED Talk and not the fruit company one. So I'm actually surprised that this many people are even here right now. But I guess someone should probably close that door. I don't know. My name's Carr. I am infrastructure engineer at Michigan Software Labs. We're a small custom software development shop in West Michigan. So I started out in IT in the mid to late 90s, working with like Mac OS System 7, worked at a value-added reseller, worked at the Apple Store. Then I went back to college, got my piece of paper, and then got a job as a mobile app developer for about, and I still work for that company, but as our company grew, we needed someone to do like IT and audiovisual stuff. So I kind of volunteered to be that person. So I'm back in doing mostly IT, but I work with a bunch of programmers, and I had to learn Git because it's a pretty important tool for developers. But I think it's an important tool for lots of people nowadays. So I figured I would try to help share some of the knowledge that I have about Git to people that don't necessarily have it or want it. So why? Well, the odds are that you have users that are already using it, even if you're not. More and more systems are using text files for infrastructure as code. And Git is often the method that you get those text files to wherever it is that your thing is running. You can also use Git to share and collaborate with other people on code or documentation. What's that markdown editor? Obsidian, I think, is an example of one that kind of encourages you to use Git, even if it's literally you, which you can do. Git is also nice for keeping track of changes and your old versions, particularly, I mean, not that Apple doesn't do that automatically with, I don't know, the Time Machine snapshot, blah, 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 blah. But, you know, if you don't believe in that stuff, or if you're using, you know, Linux, Arch Linux on your Dell laptop from 2008, you can use Git. Now, pull requests and merge requests are not technically part of Git. They are what services like GitHub, Bitbucket, and GitLab offer as part of using Git. And that's part of the collaboration, but they're technically not Git. Git is just a stupid program to take care of your files. So, yes, I think the slide says it all. Git is a distributed version control system. Linus coded a basic version in less than a week to replace a commercial program called BitKeeper after its license was revoked for use with the Linux kernel. So this is the guy that wrote the Linux kernel, still manages it. He also wrote Git. Torvalds sarcastically quipped about the name Git, which means unpleasant person in British English slang. Quote, "I'm an egotistical bastard, and I name all my projects after myself. First Linux, now Git." It's all true. So, thank you, Linus. Okay, so what does Git do? It keeps track of mostly text files and the changes to them, also known as a diff. So on that image there is just a screenshot of some code that I worked on in a GUI editor. And so the red is like, hey, this is the old version. The green is the new version. If you look closely, you can see that this GUI editor actually highlights the characters in the line that have changed in a darker green. So you can also get these sorts of diffs. Diff is just short for a difference in command line tools. Personally, I find that it's a heck of a lot easier to use a GUI thing for looking at these, but whatever, you do you. I'm not gonna tell you that you can't use the command line for everything. Git can also track whatever random binary files that you might have, images, executable blobs, etc. There is a separate add-on to Git called Git LFS for large file storage. It does not come with Git, you have to add it, but it works with Git to facilitate storing big files and changes to them in Git. So, but like smallish files, you don't have to necessarily use LFS. It's when you start to get a project that has hundreds of megabytes that you're going to be sad when working with your Git server takes forever. And that's where LFS comes in. Git also is facilitate copying files around between machines. So, a lot of people think of like, oh, well, Git has the server. That's like GitHub, GitLab, whatever, and then I'm the client. Well, that's technically not true. Every machine is just running Git, and Git just takes care of talking from your computer to the other computer. And normally, you're initiating that contact. Like the server's not going out and talking to you. Theoretically, it could, but that's not really the way that people have ended up using it. So, we'll go over a little terminology. I don't think it's super important to know all of these terms, but it's not a bad idea to understand or know that they're there, because you might read documentation or you might be Googling something and you're like, oh man, what was that called? Or you read some Stack Overflow answer from 2008 that talks about something and you're like, what is this guy even saying? Because the thing is Git has not changed that much, but yet they've been trying to improve it. Because I think Linus Torvalds literally created it in like 2007 or something. So the working tree just means the stuff that you have in Git. Repository, mostly known as repo, that is like the thing that you're storing on the remote, on the server. It's also like your folder on your computer that has all of your stuff that you're putting into Git, your code, your files, whatever. Commit. So it's a noun and it's a verb. Git loves overloaded language. I don't know if we can blame English or what, because Linus Torvalds is not a native English speaker. So I guess we just blame English. Branch, that is Git's secret sauce. It is basically just a name for a pointer to a commit. So a commit is just a snapshot of your code at some point in time that you saved. And then a branch is just like, hey, this branch called main points to this code that existed at this time, and you can have multiple branches, so we'll talk about that more later. Remote is the name for the server. It's just another computer running Git. Typically also a bunch of other fancy stuff like a website for pull requests and whatnot. But some of the DevOps kind of things, like AWS or whatever, there might not be like a website for AWS code commit. It's just like that's where you have to set up your remote to deploy your infrastructure as code so it can build your new applications because you got updates or whatever. An object is just the generic term for something that you have in Git. Files, folders, commits, that would be the noun as opposed to the verb of I'm making a commit, or I am going to commit these files. And tags, tags are just extra special branches that typically live around forever. A hash is that really long, unique set of hexadecimal letters, which just means 0 through 9, A, B, C, D, E, F, G. It's technically a SHA-1, Tech's supposed to be unique. I believe that there's so many commits out there that probably there are not, you can't say that they're truly unique anymore, but the odds of your particular repo ever having duplicate commits is pretty low, so don't sweat it. So I mentioned tag. A tag is just a long-lasting name for a specific commit. Tags are often used for releases. So like, hey, we're going to release version 2.1 of our blah, 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 blah. And so you can put version 2.1 tag on this commit, and that way, if you have some bug and you're like, oh man, why does this code broken? I've been doing all these other things, but I need to test this other code. You can use that tag and go back and just look at the code for that point in time for that release, because if you did it right, that code is what is running that version of your app. So that's what tags are for. And then diff, just short for difference. It's the versions between files. Any questions? Speaking of questions, feel free to raise your hand or just holler out if you have questions. I don't care. I won't be upset if you want to interrupt me. Also, I apologize. Yes?
The tag, is that set automatically?
No.
You have to specify.
Tags, so he asked if tags are automatic. Not at all. Nothing in Git is automatic. And that's probably an incorrect blanket statement, but I feel like it's pretty manual, anything that you do. So yeah, a tag is just an extra command that you say, git tag, blah, 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 some name, version 2.1, and then it will create a tag that will be attached to that commit. So, blah, 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 blah. Let me go. Okay, so here is some of my code, and you don't really need to know what any of this is, but hopefully you can see that this icon here looks a little different than those other icons, and it has a weird little price tag looking thing on there. So that is when we actually cared enough about this project to version it and put tags on there. I think it was also because our continuous integration system does a build to production and tries to deploy it automatically if we tag a commit. So that's another handy use for tags, is you can do things in systems like GitLab, GitHub, or whatever, say hey, run a production build when I tag this commit, and then you don't have to go into GitHub Actions and click a button or whatever. You can just do that, and then hopefully everything goes well. I also apologize in advance that I'm not a graphic designer, and so if you're OCD, you can leave. Or I won't be upset if you feel the need to leave. Cool. So, some basic starting out stuff. Git init just creates a new blank Git repository. You can perform that command in your shell in a project that you already have. So if you already have some files and folders, whatever, git init will create a new blank Git repo in that folder. It can also literally be blank, and then you can just start adding stuff to it. Speaking of add, git add dot is basically the very simple, put everything in this folder and anything below this folder recursively. Do you know what recursively means? Okay, cool. And it will basically get those files ready to go into Git. And then git commit -m is hey, this is my message for my commit, initial commit, because who doesn't want the first commit in their Git repo to be initial commit? I don't know why. It's like hello world, seriously. So another very basic thing that if you do this, your coworkers and people on the internet will not berate you, is use .gitignore. So that is a hidden file that you put in your project directory, and it tells Git to ignore these files. Like good old .dsstore. If you commit .dsstore to your GitHub open source project, people for sure will think you're a noob. Which is okay, because maybe you are, but still. You can also have a global gitignore, which probably dsstore belongs into, and that's basically something that you put in your home directory. Like git config is a whole separate topic, but you can, like it's a text file that's called .gitconfig that you put in your home directory that you can put a bunch of stuff in, such as what is my global gitignore. That's an example of things that you can ignore or what kind of rules you can put in there. And then those links are to some, like that screenshot is from one of those websites. But that's good, because you know, the other thing that you can do, and this is a good security thing, if you are running something that has API keys or other stuff that you need to have for like testing or whatever, and you want to try to make sure that you don't accidentally commit those, because that's also bad and it will get you shunned. You can put the file that might have those, which is very commonly a .env, but it can be whatever. You can put that in gitignore, and Git will never purposefully track that. So it won't go to the server, it won't leave your machine. Any questions? Cool. So let's get some code. That's a screenshot of my GitHub and the dumb little demo project that I created. Git clone is how you make a copy of a repo on your own computer, and you're basically, by default, making a copy of everything that is on that remote project on your own machine. So if it takes forever, your internet is slow, or the project is huge, or both. But for like my tiny little project with 4 files, it should be, you know, lickety-split. So in GitHub, that little green code button pops up that little window where it gives you a couple different options for the URL. So git clone and then some URL. And it will put that project in a folder on your computer called demo, because that's what my repo is called. It's called demo. And then underneath that demo folder is where the hidden Git folder is, and then my code. Those HTTPS and SSH are the 2 primary ways of getting code from a remote. If you're open source, just getting stuff from GitHub, you can probably just do it. It's not going to require anything. But if you're like, if this is for work, or you know, I don't know if GitHub actually requires people to be signed in to do stuff, you might have to worry about authentication. SSH is basically like a text file that you put in a place on your computer and make sure that your GitHub profile knows about it, or GitHub can walk you through creating it. All the various servers support both of them. I personally prefer HTTPS because it works like in the coffee shop with the weird firewall or your kid's school. Whereas SSH will sometimes get blocked, and you'll be like, dude, why can't I push my code? And it's because the SSH port, which is not normal if you're a network administrator at a school, whereas HTTPS is like their firewall can't tell that it's not just, I'm going to a website. So when you clone a new repo, you are typically going to start on the main branch. If you have checked out old code, it might still be called master, but the default for any new project is the primary branch is called main. but you will definitely see master out there a ton. They're basically the same thing. They just changed the name. Any questions? Okay. Cool. So making changes. This is another screenshot of making some changes. Oh, hey, look, that's nudge. Or no, yes. No, that's manage software center, annoy your users to do updates. So that's an example of, it highlighting, like, I just changed it to those numbers. And I find it humorous that 16 and 17, it's literally just like, nope, you just changed one number, it's cool, man. So, doing a commit, one thing that you want to understand, you don't really have to, but you probably should, is the staging area. It is where you prepare your commit. You don't really have to utilize it. I don't know if you might remember from the earlier slide when I did git init, git add period. That is essentially taking a new file or changes to files and putting them into the staging area. You don't have to, when you make changes or add new stuff, just run git add dot every single time. Because the stuff that will get committed when you're ready to do that separate thing is only going to be the stuff that's been put into the staging area. So like you have your files, Git is keeping track of like, okay, you created these new things, you have these new changes in an existing file, but if you haven't staged them by adding them, they will not actually get committed. So does that make sense? So like so I'll just go here. I'm typing into my README. I'm saving. So this is my diff. So this is my preferred GUI editor called Fork. It is not free. It is, however, nagware. But if you like it, you should pay for it. Because, software developers need to eat and buy beer. This is GitHub Desktop, which is free. Personally, I think it's garbage. But that's because I'm highly opinionated. Whatever. So Git is like, oh, hey, you changed this file, readme.md. It's not staged. So that means I have not added it because I'm not ready to commit it. So you can use the staging area as like an extra level of undo if you want. Like you can put stuff in there because you can like get rid of changes like in Git. Like if your editor itself, or if you've done too many things, that undo is going to be a pain in your text editor. You can undo things in Git, in the command line or in a graphical user interface. So just know that when and if you're just like doing basic stuff in Git, you can just hit git add dot and it'll just put everything in there and then you can commit it and it's fine. It's not like that's bad. It's just know that it's a thing if you want to use it. So git status is the command line tool that kind of builds that, what you saw in my GUI tool. It's just saying like, oh, hey, you're currently on the main branch. It looks like you're up to date with the last time that I did a fetch. Talk about that later. You have some changes to your test script, but then I also noted that you have this new file that I haven't tracked, and that means that you haven't put it into the staging area yet. So this is what it would look like for this. Like I have that little green dot, which means like, hey, that's a new file, and then that test script is a changed file. You can also use git diff, and then the name of a file, and that needs to include the full path in your repo. So if it's like underneath scripts or SRC or something, you need to specify the full path when you're doing it in the command line. This is what it looks like in the shell. The green and red, it's not quite cool enough to highlight the specific line, at least not with what I have in my shell, because I do use the command line, but mostly for like scary things that I want to make sure that I really understand what the heck is happening, so that there's no like automaticness that might be possibly happening. So here I added those files. I check the status. It's like, oh, hey, cool. You have these things ready to be committed, this new file and this modified file. You can see they're in the staged part of my GUI, and I even started typing a commit message in there. Cool, so now we're ready to actually commit. It's a good idea to fetch before you're committing, just in case there might be any changes on the remote, which is the server. If you are just solo person doing Git on your own computer or pushing it remotely, if you only have one computer or you're only ever pushing from one computer, that part's not as important. But if you are collaborating with other people and you have not fetched, you could have sad day. We'll talk about that later. That was literally like, I think when I first started learning Git is when I went back to school, and we were in a programming class, and like one of the dudes in our project group was like wizard. He said, oh yeah, we gotta use Git, and like none of the rest of us had a clue. So every time he pushed code and we would all try to do it, and we were just like, oh my God, what's happening? So that's when I was a student. Now I'm a professional. So when you are collaborating with other people, a well-crafted commit message is very helpful. And there are literally entire blogs that you can read about a well-crafted commit message. So I'll let you research those on your own. If it's you, really the only collaborator is future you. So what would I want to remember about this change is my mantra. As a reformed programmer, I have definitely cursed past me. That is an example of a commit done from the command line. You might think, oh, that's kind of weird that like there's two -m's. Well, that's because a commit can have a title and then it can have a body. And the title is the thing that shows up in that little table in my list of commits in my GUI. It's also typically all that shows up when you're looking at like a list of commits on a website like GitHub or whatever. So if you do like I did in the command line there, the first string will be the title, and then the second string will be the body. And my editor has, that's why it literally has like two different fields, one for the title and then one for the description. So Git will not let you not have a commit title. So, although it won't stop you from typing blah, 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 blah. So, actually that's not totally true. There is a command that you can run to do an empty commit. So, it gets weird. Oh no, I made a typo. So this is kind of advanced, but if it's just you, or if you have not sent anything from your local computer to the remote, you can usually do this sort of stuff and not be in too much danger. I made a typo, and I also wanted to show how fancy you can get with the shell, if you use a double quote, you can literally hit return, and then it will put like a new line in your commit message, so you can have like multiple lines. But ironically, the new line escape character does not work. FYI. Or if so, I don't know how to make it work in my shell. So -- amend is going to rewrite the previous commit. So if you made a typo in your commit message, or if you're like, oh man, I misspelled this code, or I created this new bug, but I know what it is right now, and I don't want to make another commit that says fixed the dumb thing that I just did. You just want to fix it. Amend is a way to basically just rewrite the history of that previous commit. So yeah, that was my fancy tip. Any changes about committing yet? Yes?
Quick question. When you, let's say you find someone's code that you like and you want to build onto it for your purposes, and you clone their repo, when you're doing these commits and these changes, you're only affecting your repo. You're not doing anything going back to the originators.
Correct. So it was asking about, like, say that you've cloned the repo of some open source project and you're making changes on your local computer. What is happening to the code on the original code? Nothing. Nothing that we have covered yet has had the capability of making any changes on someone else's code yet.
All your commits are only affecting your repo.
Correct. Correct. So that he's asking about the commits in your own repo, and that is precisely correct. So Git is a distributed version control system. So it means that each person has their own fully functioning local copy of the code. And all the stuff that you do on your own machine is purely for you until you tell Git, send it somewhere else. And we'll talk about that. Does that make sense? Cool. So this is just a little bit more about committing. If you type git commit on the command line without a message, it will pop you into a text editor. Because it's like, yo, you need a commit message. If you don't have one configured on your machine, you'll probably get Vim. To quit out of Vim, it is :WQ. Yep, it's like, that should be, I'm pretty sure it's on a shirt. But you can configure your computer with an environment variable to launch the text editor of your choice, which in my case is Sublime. But you could use Nano, Pico, which are slightly less obtuse CLI editors, or BBEdit, whatever. Those tools all typically have some sort of instructions for, like, hey, how to tell the command line level of your computer to use BBEdit. And then it'll open up whatever it wants in your full text editor. VS Code, same way. In fact, I think if you install the command line tools for VS Code, you can literally just like tell it to run code, C-O-D-E, and it'll fire up VS Code. Cool. All right, so branches. They are kind of the whole point of Git. So this is just one representation of a few different branches. Why did they choose the word branches? Guess because computer scientists are big fans of trees. If you go to computer science school, you will learn about trees in ways that you didn't ever want to. But basically, I mean, it is kind of true in, like, your commit is kind of like a reverse tree, depending on how you want to think of it. Like, it has the top level, it has the root, And then as you split off, it has branches, and those could be like your features or bug fixes. Branches are mostly for collaboration. Even if you are creating a branch that only you are ever going to work on, say your coworker is working on some other branch that only they are working on, and then later on down the line, it all has to get reconciled. But you might, be working on the same branch with other people. I believe there's literally another workshop this week about Git ops, which is really more about like how do you use branching and other fancy Git stuff to make your life easier in IT world. The other thing about branches is they are very cheap / free, so that you can make as many as you want. It doesn't hurt to have a bunch of branches locally on the remote. You can safely delete them later. If you're like, oh, I want to try out this blah, 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 blah. You can create a new branch, and then you know that you're like leaving the good code that you know is working untouched in the main branch, and then you can mess around with this other branch as much as you want, and if you totally screw it up, know that you can safely just go back and throw all that away and go back to main, which you know is good. So that picture there is kind of like a typical develop versus main for some sort of app project. Like the main branch and the develop branch probably exist always forever on a big project. Main only has commits on it that are like, hey, we're deploying, this is production. Whereas develop is a lot busier and has like, hey, this is all of the stuff for the work that's in progress. And you'll notice that there's like arrows pointing, like basically some of those branches, some of those commits for main, they're probably exactly the same as a commit that was on develop. So I know I probably just confused a lot of you, so that's why I went to this slide. So a branch is literally just a pointer to a commit. So there's really nothing special about them. Each one of those little circles, each one of those commits has a SHA. So the stupid 40 character ABCD 019 blah, 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 blah. And you could never use a branch name in your life and refer to every single commit with those 40 character names if you wanted to. Just like you could browse the internet by typing IP addresses all day long. You could, no one's stopping you, but that would be a little weird. So branches are just an easy way for a person to like understand where the heck am I in this code? How can I identify this version of the code from this other version? So that's really what a branch is it's just a way to say like, hey, here is a pointer to this version of the code. I'm calling this code little feature, and I'm calling this other code big feature. Now it gets a little more complicated when you start to talk about like, well, when I created this branch, because this is like a separate offshoot from main, where was I? And how difficult is it going to be to get back if I do want this code and I want to put it into production? And we'll talk a little bit about that more momentarily. Any question about that? Yeah. Okay. So here's a common way that people work. Main being your release or production build, develop being your active work. Teams will often have a naming convention of some sort so that they can keep track of, like when they see branches, like, oh, what the heck is this? My team often uses feature or bug fix. Sometimes we literally put the name of the issue ID from Jira into the branch. if you're using project management tools like that, you can set them up so that like the GitHub can know about the thing in Jira and vice versa if you put those issue IDs into your branch or your commits. So switching branches. So like I mentioned earlier, when you start out, you're typically just on the main branch. If this is a new repository, it's not going to have anything else. It's just going to have the one branch. So how do you switch between them? Good idea to run fetch. Fetch will actually tell you what all the branches are on the remote. You can also manually list them out. Git branch -- all. Git checkout will switch your code to a branch. Git checkout -b will create a new branch from whatever the code that you are on right now. That's the default. So if you're on main and you want to create a new branch that started from main, so the root of that branch is from some commit on main, that would be how you would do it. So here's like a whole bunch of branches, and the nice thing about this program is it actually organizes them in these little folders. So if you call it bug fix /, it then puts the commit into that little folder. And this, like, these commits have some sort of branch attached to them. That's why they have that little label. Some of these branches either never got merged, never got deleted, or were garbage and could be deleted. So, FYI. Like, I don't even know where, oh yeah, okay, branches are like way the heck up here. So, I don't know. These people really need to clean up their stuff. I know as well that the developers that make Git, because it's, you know, free software, blah, 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 have been trying to make it less obtuse. So there are some commands that probably didn't exist when I learned how to do Git that make switching around between branches maybe not quite as obnoxious. So, FYI. So now we're starting to get into doing stuff with your code somewhere else than on your own computer. A remote is just some other computer running Git. You can have more than one remote. It's not common, but I, as a person who is often doing DevOps nowadays, where your code is stored for your collaboration might not be where your code is going when it gets deployed. Our company has used Heroku for quite some time. And one of the big selling points about Heroku back in the day was, oh, it's so friendly for developers. You can just push a commit and it'll deploy. And that was actually really cool back in like 2014. We're just like, whoa. And so you would literally have a separate, so when you do a git init and then add a remote, by default, the name of that remote is going to be called origin. I don't know why, it's just what they chose. So if you run commands that are working with a remote and you don't specify like GitHub, the thing is like when you clone from GitHub, you're not going to get a remote called GitHub. You're going to get a remote called origin. Unless you have said, please name this remote GitHub, in which case it will happily name it whatever you want. But by default, if you just do git clone, blah, 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 you will get one remote. It will be called origin. And that is the 90% of the time all people have. And just having one is fine. Make sense? You can also add remotes. If you create a new repo on your computer from scratch, this is not you cloned something from GitHub. This is like I created one on my computer. You will not have a remote. You will have to add it. Most of these platforms that host code for you require that you create the repo first. Like you can't just push to GitHub. You have to go to an account in GitHub and say, I want a new remote, and give it a name, and then put that URL into your git remote add the URL. So FYI, don't forget that. I mean, that might not be universally true. And I also know that like GitHub has a command line interface that could probably just do it automatically for you, but it's literally using a tool on top of Git. Like it's not pure Git, it's the GitHub CLI. Cool, so now we're talking about remotes. I keep mentioning fetch. Sorry, I'm trying to save you from yourself. A lot of the GUI clients will do a fetch automatically, like periodically, like every 15 minutes or whatever. It's particularly important when you're collaborating with people. Doing a fetch does not actually change anything in your local copy, but it will tell you if things have changed on the remote. So there's an example of a fetch that I did earlier that was like, oh, hey, they deleted these branches that you were working with previously. Oh, hey, here's this new branch. And you can list all the branches that you have or see them in your GUI. So a lot of people probably see this command and assume that that's just like what you're supposed to do. And yeah, that's okay. However, I feel like this is one of the things that I wish that more people understood is that pull really isn't a command. It's actually a shortcut for two commands. It does a fetch, and then it does a merge or a rebase. And merge is a little scarier. Fetch is fine. Fetch is harmless. And if everything's honky-dory, git pull's probably fine too. But you should at least know that it's happening. Because GitHub literally calls pull requests because of the command git pull. I kind of appreciate the fact that GitLab calls them merge requests, because that's really kind of more accurate. But whatever. So if you do that command git status, it will tell you if your current branch that you're on is behind, and whether you can do a simple fast forward merge. Now, a fast forward merge is the easy type of merge and not scary. It basically just means that your commit locally can just zoom ahead to the new version that's on the server without having to hassle with merge conflicts. And because those are where you start to realize why people hate Git. So here's an example. See how there's that tiny little number 19 with the arrow? So that's my computer after it did a fetch with GitHub realizing that my main branch is, whoa, super old, because this is my local copy, because it doesn't have the little GitHub icon on there. And then actual main is way up here. But because I haven't messed with main on my own computer, I can do what's called a fast forward, and it'll just boop, switch my copy of main to be exactly like the copy on the remote. And fast forward merges are happy, easy, shouldn't have any problems. And if you do them first, you probably won't have many headaches, probably. Question about pull, because now we're going to talk about merge. Not a whole lot, because, again, this is potentially a whole nother topic. If you're a solo person, you'll probably never have to do a merge, like a merge conflict. Talked about fast forward merges. You're just pulling in updates or changes. The most often thing that happens when you get stuck with a merge on a small project is if you forgot to fetch, someone else pushed, and then you get the dreaded error message from the next slide. Merges are not the end of the world. They just can be tricky and or a lot of work. But there are tools that will make dealing with merge conflicts less annoying. So here's a screenshot of a merge conflict in VS Code. I actually think VS Code does a pretty great job of this particular type of situation of a merge conflict. Basically, this is some file where the middle blue part is the proposed change. The green part is your change, and the bottom part is the original change. And so basically, Git is saying like, yo, you changed this file. This other person also changed this file. I can't figure out what this file is supposed to be. Sometimes it can. Sometimes the changes are simple enough that it figures it out. That being said, check it. I would have never thought to use the word hallucinate with Git, but it seems appropriate. And so in those buttons across the top there are like if you know that the change that you're pulling in from where you're merging from can blow away what you have on your computer, then you can do the incoming change. The accept both is where you're like, Git, please try and figure it out for me. Good luck. Or you can just manually go in and fix it yourself. It does when you're in a merge conflict. So Git goes into this special mode, and it literally adds those arrows in the word head and stuff into your code. So if you use a merge tool like VS Code, it'll delete those things after you're done if you choose one of those automatic options. But if you choose to do it manually, remember to delete those things. Otherwise, you might wonder why your script fails or your thing doesn't compile, because it's like, I don't know what arrow head is. Okay, that was merge. Stash is another command that's helpful to know about, and it can potentially get you out of a jam if you are in a merge conflict situation. A stash is basically just a temporary place to put changes for files that's not a commit. It kind of works like a mini commit. The most common time that I, and probably a lot of people use them, is when you have tried to pull or merge, and you can't, because it's like, yo, you have stuff in your working directory that would get blown away if I pull in these new changes. And Git tries its best to keep you from doing stuff that will delete your own code. And it actually recommends, like, hey, either commit this stuff that you have that's changed or stash them, and then we can pull. Because when you do a pull, a merge, it would prefer to have everything be nice and clean so that there's no changes and less merge conflict possibilities. So a stash makes a thing that's kind of like a commit with your staged files or files that you've modified. This is a weird thing, but if you've created a new file in stash, if you've created a new file and you're trying to pull, because you haven't tracked it yet, and so when I say a new file, like literally command new, my new file.txt, it's not in Git at all. Git doesn't know about it at all, but it is a new thing hanging out in there. But because Git doesn't know about it, it doesn't care. So it doesn't bother to stash that because it theoretically shouldn't be blowing anything away when it's pulling in changes. And of course, you can do it exactly the way that you want with different options, because Git is highly configurable. But yes, one of the most common things to do with a stash is to save your changes, do a pull, and then reapply them. So stash apply just takes that and puts it back into your code, but keeps that stash around. Pop literally applies it and then deletes it. So here, and you can have multiple stashes. And you can also give them names. You don't have to, like you can literally just hit git stash and it will save one. And I believe that Git by default does the goofy @braces number thing that you'll see sometimes when you're doing fancy Git stuff. But in my GUI, I can literally like apply any one of these manually. Now, if you have a really old stash or a really complicated one, you could actually give yourself a merge conflict from applying it, but then you can hit, reset, undo, essentially. Any question about stash? Yeah, so if you look at the list of them, Git is a big fan of those like @braces 0 thing. You'll see that in other places in Git from time to time. This tells you what branch that I happened to be on when I created those stashes, and then the message that I typed in for the stash so that I could try to remember what the heck it was. But if it's just something that's real quick and you're just going to get rid of it, you don't have to give it a name. Git will literally just call it stash @0. Okay, so we've got our commits. We're theoretically up to date. We are now going to push, and that means sending the code from your current branch and the commits that are a part of that branch to the remote. By default, it's just going to push whatever branch that you are currently on to origin. You can get fancy and you can specify another branch name. So you could push some other branch that you're not checked out that you have on your computer. It doesn't care. You could push to a different remote. Lots of options. If you ever want to have your mind numbed, just look at the Git website for all of the different possibilities of things that it can do. Stuff like that is usually more common for CI, continuous integration or deployment. So it is also possible that you might try to push and you are told that you are not allowed. Assuming that you have authentication set up somehow, that probably means that branch protection is turned on. And if you care at all about people not destroying your code in your open source repo, you'll want to have that turned on for at least things like main, because you don't want someone replacing your repository with a marketing website, which if you didn't have branch protection turned on, theoretically somebody could do that. So when you're talking open source contributions, 99% of the time, you're going to be pushing some branch that you created to somebody else's repo and then going through the process of creating a pull request that's like, hey, person that makes this awesome tool that has a bug, here's my change to fix it. Create a pull request, write a message about it. Some of the larger projects literally have like a giant wall of text of like, answer all these questions or you are denied. Which, whatever, it's a thankless job probably. But if it's just you pushing to your own repo, you can do whatever you want all day long. If it's you and your team, there's probably different levels of branch protection. If you're a maintainer on an open source project, then you've probably got a level of permissions to do things that like Jill off of the street does not have the capability to do. So that's pushing. That is how we get our code from our machine to somebody else's machine. Push. Oh boy. So you'll see this a lot. I'm pretty sure Git still uses this error, which is like really dumb, but I don't know, maybe they're starting to make it more user friendly. Refs are just another name for commit. References. So I think technically those hash SHA strings are called references. So probably you didn't fetch and merge and Git is telling you like, hey, we can't just take these changes because there's already changes to these other files. So you got to do something first before we let you push it. If you're lucky, my little trick command there, those are 3 different commands. Stashing your changes, pulling. That FF only stands for fast forward only, which means the simple easy merge. And then popping the stash, which is going to apply your stuff back on there. And then commit it. Hopefully no merge conflicts. If you really like to live dangerous, you can read about git push force. Definitely should not allow people to have permission to do that on your stuff unless they know what they're doing, because it overwrites the history on remote. If you're working by yourself, probably, whatever, you can do it all day long. It doesn't really hurt anything. But if you're on a team, forcing can be dangerous. However, if you have good communication or procedures in place, forcing can be part of your normal way that you work. It is at the place that I work at. This extra special version of force with lease, basically attempts to have Git warn you when you're trying to do a force push that you're going to nuke somebody else's work if you do this. But theoretically, you should be in communication with those people anyway. Because essentially force pushing is usually required when you have done something like an amend. So I showed earlier, like, oh, hey, I made a typo. I want to fix this error in my commit. Well, if you're trying to do that with a commit that you already pushed, you are now changing something that is already like written in stone in history of Git world. And Git will let you overwrite that. I don't know, get out the sandblaster, whatever. But you got to be prepared to know what you're doing. So another common thing that you might use force for is rebase, which is a fancy kind of merge that if you become more familiar with Git, or if you're on a team with people that are more familiar with Git, I highly encourage you to use rebase because it can make the history of your commits cleaner. Because if you, let's see, do I have, so we don't really have any commits in here that have the word merge. There's one. So this was a commit that literally only existed to facilitate a merge of nothing. But you know, whatever, it's not like it hurts anything, but like if you want to browse through your code and be like, oh, you know, what was happening there, this is a more typical merge where like, hey, these are all the things that I brought in merging this branch to this other branch. You can minimize those extra merge commits because like every time you have to do a pull on your own computer and you need to update something and you get a merge conflict and you just fix it with a merge and push it, you're going to end up with one of those those merge commits. And so you might, if you were working on this branch for 2 weeks, you know, you might end up with like 2 or 3 versions of that. And some people think it just looks dumb. Like, why do I have these commits that don't tell me anything other than Jill merged the feature branch into her main? Cool. But again, I also work with a team of OCD programmers. So, reset, sort of advanced, but can be useful. Ironically, the most commonly used one is the most dangerous one. But it's basically like, say that you want to go back to an old version and you don't care about any of the changes that you have or you've already stashed them or whatever. Reset -- hard will basically reset the code and everything in your folder on your computer to some version of the history at a branch or an old commit or whatever. And so sometimes that can be helpful. You know, maybe you made a bunch of changes that are horrible and you want to get rid of them and start clean. Maybe you need to troubleshoot some issue on some other old branch and you want to switch over to that and make sure you don't have anything lingering around from newer versions. A soft reset is typically more for you might have made some changes, but the ones that you haven't staged, you're okay with getting rid of. So that comes back to the, is it staged or not staged, or is it a new file or not? The mixed one, honestly, I tried to read about it, I didn't understand it. So I apologize. I guess probably because I've never used it. So that was my 2 cents about reset. One more fancy thing is the ref log. One of the things about Git is that it pretty much tracks everything. So under the hood of Git is this thing called the ref log. And there's a little screenshot that shows some of what it keeps track of. It literally keeps track of, like, I switched to this branch. So it's not just commits and stashes. Now it doesn't track the individual changes to your files. but it basically keeps track of or logs anything that you've done related specifically to Git. And so if you really screw something up, the odds are pretty good that you'll be able to undo it with some sort of fancy stuff with the ref log. Now, I wouldn't want to talk about that right now. And if you've pushed and you are doing stuff with the ref log, inevitably you're going to have to force to get it fixed. But that being said, like I have done things that almost made me cry to my code, and then my coworker helped me figure out like, oh yeah, here's the thing where you accidentally switched to this branch and didn't stash everything. And then the only thing I lost were new files, because if you haven't tracked them at all, they're not going to be anywhere in Git world. But if you ever staged some version of a file, it will be in there, and you can get it back. So that's the ref log. If you would like to know more, those are two good websites. Atlassian makes Bitbucket. GitHub has a pretty good one as well. I like the Atlassian one because it has a weird vibe between like super complex stuff, but then also pretty simple stuff. Like it's real weird. Like you can skim over the like, I don't really care about this example right now, but still get some good stuff out of it. Any last questions? Because we only got a few minutes. Yes?
You mentioned rebase quite a bit.
Yes.
Maybe I missed it or not, but
I did not talk about rebase.
can you just like explain that a little bit? Because I know it's like an alternative to merging where you kind of stack your commits on top of it, right?
So you're thinking of an interactive rebase. So rebase is basically trying to resolve the merge with an existing commit without having to create a new commit. And there are some things that you can do in your config that make it a little easier. But yeah, basically you can, because there's also squash, which is like rebase but not the same. Squash is pretty common nowadays for big repos where they make you squash. So say that your branch has 8 commits and you're making a pull request and they make you squash it. And you can actually do it through the GitHub website now, where they just like dump all of your commit messages into one giant commit. Interactive rebase will either take you into a program or into like your text editor, and you get to choose like, you can either choose commits or you can do a step-by-step where it'll be like, oh, okay, this file and this commit has a conflict, fix it. So you see that weird merge screen like we showed from the VS Code screenshot. And then save it, go to the next conflict, save that, and then it will rewrite those, like if you pulled in 3 commits, it will rewrite those with the changes from your computer. And so then in order to get those to the remote, that's when you have to force push. But that's when you need to let your coworkers know, like, hey, when I did a rebase, I had a merge conflict. So make sure that you, coworker, up to date, so that you get those things from me so that you don't later have sad, totally horrible merge conflict on their local machine. So thank you very much. My name's Chris. Hope you enjoyed it. Leave honest feedback.